Just in interest of time, I'd love to kick things off and get started here. So I'm really excited to have Sam and Kobe here from the Databricks team. We are going to be re-recording this session. So we're going to try to post it on the YouTube channel, the University Alliance YouTube channel, which I'll send a link here um, later this week. And welcome everyone. So this is going to be a talk, Kobe and Sam, on custom LLMs, so training and fine-tuning LLMs to optimize AI application performance. And Sam and I will be moderating the chat. So throughout the session, if you have any questions, please drop them there. If everyone could just turn off your audio for this presentation, and we'll have time for Q&A at the end. And also, when questions pop up, if they make sense to answer throughout the presentation, we'll catch those. And then we'll send out the recording to the link and slides if we're available to send that out as well. And yeah, I'm going to pass it over to Kobe and Sam, and we'll get started here.
Thank you, Karen. Really appreciate that. Hi, everyone. I'm Kobe Crawford. We're going to just go through a presentation about the rationale behind customizing large language models as needed for people's applications and where things are most applicable, or finding the right priorities for when to do that and what approaches to take. I know this is an academic audience, and so you're probably going to want to have a number of questions that might not be covered as deeply in the slides, but we're going to be doing our best to make sure we have good answers for you across the board. So please feel free to put the questions in the chat, as Karen already mentioned. Just so getting things going here, I'll just kick in the slides, get the screen sharing on our way. And here we go. So this talk is about customizing LLMs when training and fine-tuning are valuable, and what goes into that. Obviously, we're doing it from the perspective of Databricks, so some of what you'll be seeing will be specific to how Databricks offers these capabilities. And as we just get started here, I would love to make sure to introduce both myself and my colleague Sam Raymond, who is here online. Will be monitoring the chat, and as needed, if we need to do the verbal Q&A, he'll be coming in to make sure to ground what we do in all of the things that are backed by the academic research, and making sure that people understand the things all the way down to the core of what people are finding in the academic literature, in addition to what we're finding in practice in terms of what we're doing as we put this out there and make available the features and functionalities of Databricks for the enterprise customers. With that bit there, it's really key to understand and appreciate that what we want to do here today is kind of cover things as in a broad-based kind of way. We've got a lot of content. In fact, I'm relatively certain I have more content than the 50 minutes would typically hold. So I'm going to do my best to be crisp, and that's where the Q&A and typing it into the chat will really help, so that as Sam is responding to those questions, that if you're having concerns or thoughts there, that you'll have plenty of opportunity to get those questions answered. I do have a live polling feature going right now in our slides, so you can use the QR code here, or type in the URL, pollev.com/Kobe Crawford 176. One of these days I might pay up to get the custom short URL for that, but at the moment this is it. And just to get things started, and just to have a feel for like our team, who's here in the audience with us today, I have a quick question for you. Just click on the map somewhere, where you were born, just to get a feel for where we are, where our audience is coming from, and just as a way to sort of like break the ice a little. And again, pollev.com/Kobe Crawford 176. And I can also go back to that URL really quickly if it's useful. Don't know how big our audience is today. How many people we have? 22 so far. Okay.
I was just trying to put the link in the chat so folks could access it.
Sure thing. Good idea.
All right, got it there.
Fantastic. Very cool. Uh, so it looks like a pretty good global distribution. Um, yeah, so it's wonderful to see. I'm really glad to have this. I will give it just another couple seconds and then we'll just move on from this. Don't want to get bogged down on it, but I do love seeing where everybody's coming from when we have these talks. And uh, it's always a great reminder in general that the things that we're talking about uh, do ultimately have some we can see the global impact in our conversations. All right, and then since you're now in the interactive mode and you've gotten the URL, if you're thinking about building something sometime soon, what's your next AI-based application? What are you thinking about building next? Yeah, I'm really, a lot of things. The chat interface is being popular is one of the things that's really clear in the moment right now. But it's also interesting to be thinking about where the growth areas are coming. I think the multimodal use cases are going to start to really find their stride in the next, well, I guess just about anybody who's been playing with these lately knows that making predictions is a fraught with risk. So I don't want to say anything too cavalier, but at the same time, I think in many cases the situation seems like the most important learning that we have is figuring out what are the right interfaces for humans in this. What do we want to provide as an interface for people when they are working with complex systems and trying to get things done. So obviously text and chat are working well as a UI experience, and at that level, it's a good starting point. But I think we're still at the very early stages of figuring out what the right UI experiences are broadly. Thank you very much, everyone. I really appreciate that. Let's just go over sort of the gist of what we're going to talk about for the rest of the time, beginning with the multitask generalization and LLMs and how good they're getting these days. And you might beg the question, so why would you ever need to customize them given how good they are? And then we're going to talk about the limitations to sort of answer that question, like why we might want to do that. And so we'll talk a bit about that. And then we'll get into a little bit of the how. So training from scratch, fine tuning, and sort of speaking to what exactly the formats of those bits are as far as what we're supplying to the models when we do those kinds of customizations. And we'll show what the Databricks platform can do as far as how the fine tuning interface that we're offering works. And that'll be the journey. Let's start with the multitask generalization and just how powerful and good they're getting. To highlight this, the thing I wanted to point out was a benchmark tool that the Allen Institute for AI, AI2, has put out called Wild Bench. And they're getting real use cases from people and it's kind of crowdsourcing how we benchmark models. And one of the things that a lot of people are concerned about these days is as good as the performance is getting with these models, we're also at the stage where the benchmarks themselves are being gamed a lot. The benchmark may or may not be as relevant to people's actual use cases. So I wanted to call out and let people have have a little bit of a window into the wild bench as also a way to mention, like, this is how good language models are getting at what they do. So here's an example use case from wild bench. So the prompt at the top, the scenario that's being supplied, and then uh, some annotations that have been provided for this is where we think this is going, and help have that ready as context for evaluation. And then a head-to-head comparison between two models that are included in the pool of models. And they've been anonymized so that when people are choosing their responses, they're just deciding between model A and model B rather than knowing which model is which. And they even provide the LLM as a judge GPT-4 output as part of what you get as a response. And then as a person actively interacting with this, you are now actually supplying your own feedback. And this ultimately becomes part of the scoring that happens in the benchmarking that appears on the site. I really appreciated what this does in terms of both getting actual human feedback involved as opposed to having an arbitrary benchmark, and then sort of like the complexity and the sophistication of the kinds of things that we're asking the models to do and how well they're doing it. So here's where we get the human feedback, and that's a really cool thing that's out there now, and I'm looking forward to seeing how evaluation continues to grow along with the capabilities of the models because of the very open-ended nature of what's going on with language as an interface to something to if you have a piece of software and you want to test it, the notion of what's correct as a response, it becomes far more nuanced. So these things are coming to us, and these models are more and more capable, and we see what they're generating. When we want to use that, what are the trade-offs that we're making when we're using a general model? And here on this slide, we talk about two specific things. The first one being the pricing of what you get when you're working with the API and don't have access to the model itself. And so your cost is a fixed and known thing through that interface. And if your usage is limited in a small way, then that's probably fine. The ultimate cost is not that much. But as soon as you are wanting to run a business use case that's going to have, thousands upon thousands of inferences requested per day, per week, per month, then you're going to have to look into how much this cost is ultimately going to add up. And again, you don't have control over where that cost profile lands. And on the other side, when we're interacting with an external API only and you don't have access to or control of the model that you're working with, then there are many open questions about what's being done with the data, whether your data is being used to train the next model, and whether the data that you're talking about, if it is proprietary to your organization or has sensitive information that might have privacy concerns, then are you certain that it's okay to use this model to get that work done, that API to get that done? Because behind that is I'm not sure what. There are ways to do things a little differently. With Databricks, what we're doing is we make it clear that we don't use our customers' data to train the models that we work with. And when we are offering the models in our interface, when we expose them behind an API, what we're showing you is exactly which model it is. And if you want access to that model, it's the same model that's available via Hugging Face or other things. And this provides you with a system that's providing the capabilities that you're looking for behind an API where we have different assurances about how things are working. And then in addition to that, and going forward, the idea is that you can also customize and then train and use the model that you've customized and chosen, as opposed to something that's generically provided. And then you have much more direct control over all of the pieces that are going on. So digging into those limitations just a little bit more, If your organization has data that you're working with that comes from your own business use cases, if you have information that is coming in formats that are not automatically well served by models. So like, for example, in the context of looking at the box at the top left, whether we're talking about business intelligence, this is literally how somebody's business is running. If we're talking about things in the space of data engineering, which would end up be looking at things about how the data is stored in your models. Sorry, how data is stored. We're talking about databases and what are you doing in those places and how those are being stored and formatted. The data science and machine learning use cases obviously are intrinsically like the nature of what we're typically doing with ML. Those different use cases also have a variety of data sources and also a variety of possibilities around what you need them to do. So first use case that comes to mind for me about where people have customized models is looking in the space of bioinformatics and looking at what people are doing around protein folding and these kind of things, and genomic sequencing and things like this. And it's just a different language. And so a general purpose language model, while architecturally ready to do these same kinds of sequence prediction kind of capabilities, and what are you looking for, might need to be customized to be better at it in the context of sequencing for proteins, sequencing for genes, and so on. All these data sources that your information could be coming from need to be accounted for. And one of the things that we provide within the Databricks platform is this Unity catalog that can take care of providing you with a governance of all of those data depending on their source. And when you get that kind of governance, you also can control and manage access. So at this point now, when you think about the kinds of concerns that you might have about what a general model might do, you can have use cases like the entertaining ones that people have published about a chat model that's for one company, and when people ask questions of it, the model responds with things that basically advertise that company's competitors. You want to make sure that what's going into your model is actually is serving your needs and your purposes. This can also be said for being concerned about certain kinds of bias. This can also be concerned about toxicity. These are all different arenas where you can try to say, like, we can control how this model is going to respond better by actually customizing the data sources that go into it. So when you talk about that, there's also the question about whether we're talking about continued pre-training versus other kinds of fine-tuning, instruction fine-tuning, or RLHF. And so again, depending on the use case here, and we're going to dig into this more later, the question of what inputs you provide and when you need the language model to do its part in your application, you're going to have different needs in different situations. For all of those various needs, for all of those concerns, this is why we move to customizing models as being a useful and important tool in your toolbox for delivering the application functionality that you want. Across the spectrum, that means that what we're talking about for this moment in the customization is going to be focused on the right side of this slide here. We're going to talk about fine-tuning and pre-training specifically, where the model itself is being modified. The parts on the left, prompt engineering, retrieval augmented generation, these are obviously useful and important tools. And in fact, given the power and the generality of these models, very often people can get nearly everything they need out of a model with prompt engineering alone. And getting good at prompting is a whole other conversation, an entirely other presentation. And it's very useful to know just how far you can get with good prompting. And then when you add in document retrieval as part of the process so that you can feed those documents into the prompt, that extends just how far you can go with general purpose models without any customization. And yet still at the end of it, there's room for fine-tuning and pre-training when your use case depends on it. So this is what we're going to focus on for the next little bits here. We're talking about fine-tuning and pre-training in the specific. and let's dig in a little bit on that. So how much data do you need to be able to do these things well? If you're starting on the left side and training a model from scratch, right from the beginning, um, depending on what you're looking for and the size of the model, and people know about chinchilla and other metrics that people are starting to use around how many flops per for your training that you want to get done. How much do you need there to get your model into the right space? How many tokens you need to pass? And there's like parameters coming out. People talking about like ratios of the number of tokens you want to have given the size of your model. This ends up being into the typically terabytes of data. Typically, you want to have uh, hundreds to thousands of GPUs to run. And the run typically can take weeks to months. Um, because it takes so much resource to get this done, one of the things that you want to know is when is that actually something that's necessary. And what we typically sort of like the first guideline is typically if you have a new a language that the general models don't serve well already, a different grammar, a different vocabulary, and you want to look at something that's really custom in that way, it's probably time to think about training from scratch. One of my favorite examples is the crew trim model that the Ola cab company has. They have a Gen AI subsidiary that they've created called crew trim, and they created a model, and they're based in India, and they trained a model from scratch. They worked with us on this to train a model from scratch to cover the languages, I forget how many of the languages that are spoken widely in India, but I believe it was just a couple. I think it was some dozens of languages that they covered, and so they trained the model from scratch to make them better to serve those. So that if you have somebody who speaks Kannada, then the model actually knows a little bit more about that language, and that's not typically found in the English only or the sort of like the dominant general models. Um, So that's the case for training from scratch. Continued pre-training. Typically, what you're looking for with continued pre-training is you're adding some data and some specific data to your model's awareness that um, doesn't require that the model learn the fundamentals of language alone, but it is like a specific subset of things that you wanted to understand better and to be optimized for. So this is a continuous pre-training is very commonly a use case for an organization that has their own product line or their own internal documentation, and they use continued pre-training to consume all of their documentation in a way that's essentially like less structured. It's unstructured in terms of like the text streams that are going in. You don't have defined, say, we'll talk about the prompt, the question and answer kind of formatting for instruction fine tuning later. But it's just a large amount of unstructured data, but it's broadly applicable specifically to that organization. So that's the time for continued pre-training. So that in that situation, then you can expect, like again, back to the example of advertising your competitor, continued pre-training might be the place where you would add enough content about your own product, your own organization, that you would then have the model optimized to serving and responding in ways that are specific to your business, your organizational needs. And the last one, instruction fine-tuning. This is where a language model gets optimized for the kinds of interactions that you really want you want your users to work with it. So this is where you're delivering the prompt and the response that are like these are examples of how the interactions should go, and you feed those in as examples with those cues. This is the prompt, this part is the response, and those cues then give the model its ability. Every chat model that you've ever interacted with, ChatGPT being the most famous, of course, but all of the ones that have come since have to have been instruction fine-tuned to make the chat interaction happen. And in fact, Sam, my co-presenter here, was a core part of the team that developed the instruction fine-tuning data set for the Dolly model that Databricks trained last year. And the whole point that was key in doing that was to show here's about the size of a data set that you need. Here is the instruction fine-tuning pattern, and you can apply that instruction fine-tuning pattern to more models than just what was going on a year ago. ChatGPT was still all the rage. It was still the hottest thing. And the idea was essentially for us to explain and show people that you could get that same behavior out of other models. It didn't have to be one that was hiding behind a proprietary API. So that basic idea is instruction fine-tuning is about shaping the behavior of the model. Can be applied to other situations as well. You can talk about not just a chat interface, but other kinds of things. When you want to use this in a programmatic way, for example, you might end up looking at sort of tweaking and improving things to support function calling. Something that you can see is now being exposed behind APIs publicly in a lot of cases, so you don't have to worry about the details of how that's been done, but some of that's going to be done through some of the fine-tuning behavior as well as some of the custom prompting behavior. One of the examples that we have from our work history as an organization in the past was working with Replit. Their company, if you're not familiar, has an online web-based IDE, and the entire interface is something that provides code completion and a bunch of other things. If you're familiar with having worked with, say, GitHub Copilot, the code completion experience is similar, and of course, Replit will tell you theirs is better. But when you look at how Replit works as an interface and as a sort of social platform for how to encourage kind of collaboration across software development, it's a very interesting place. They trained their Ghostwriter model on our platform from scratch. And what's interesting, a couple of interesting things about it from my point of view. One is when you look at this diagram and all of the pieces that go into how Replit organized and arranged their data and provide and did the training, I like to think about the sort of the screen real estate here as a proxy for how much work people typically need to do and in what areas. So you see how the Databricks, so this was prior to the acquisition, which is why Mosaic ML was separate from this. But the interesting thing here is that the data preparation really is actually the lion's share of the work in getting the model training to be effective for your needs. So all of this work that's done here, we often jump right to talking about training and the models because that's sort of like the most pithy new thing. But the data preparation work is actually still the lion's share of what most people do. And it's worth kind of bearing that in mind. But in addition to knowing that all that data preparation can be done, and now that we have been acquired, and now that Databricks and the Mosaic platform is all the same thing, the nice thing to also understand now is that what Databricks offers really is the end-to-end narrative. That when people have these needs, our platform takes care of providing tools and capabilities and integrating those tools and capabilities across the full spectrum of what it takes to deliver AI-powered applications in a pretty complete fashion. So we can pick apart and look at each individual feature and stuff like this over time, but it's just really useful to appreciate the full spectrum capability that Databricks offers. And this is something that I think that it's fair to say that other companies are trying to catch up to us on that. The completeness of our solution is very, very nice. Digging a little bit more into the training from scratch. Knowing why we want to do it and knowing that people have compelling needs to customize models. And again, talking about the different levels of whether we're talking about full model training from end to end versus continued retraining or instruction fine tuning. Let's just dig in a little bit about some of those bits. Let me take a quick moment, time check. Okay, it looks like we're going to be okay, I hope. Here we go. It turns out that the infrastructure needs around models at the larger scale, the infrastructure needs are significant. the best, the current thing that we can talk about the most right now is the DBRX model. And Databricks trained the DBRX model on the same infrastructure and with the same tools that Databricks customers can use. So we highlight, almost more importantly than the fact that we've trained a model that has the quality that it does and has the capabilities that it does. The key that I think is important for people to appreciate is that we're exposing the how in a way that people can use for themselves as well. So here we go. This infrastructure, when you're working with Databricks, DBRX was trained with 3,072 GPUs concurrently in the model, in the training run. And so you're coordinating communication between that many physical nodes, different computers that are all interconnected with not just standard networking, but also with GPU interconnect, something like InfiniBand or Rocky, where they're overlaying this high bandwidth communication with over fast Ethernet. This gets to be 1600, 3200 gigabits per second between nodes. And you need that between all of the node-to-node interactions. The data streaming and getting the data shuffled and distributed and managing that across the memory footprint of what's available within a given GPU's context. All of the things that go into that. There's the model training infrastructure, the environment is very pretty significant to have to do. And our platform does it across and takes care of a lot of things that people might not necessarily know about before they have to do it. If you don't have to work at this scale, then you don't know the problems you run into. But getting that stuff distributed and efficiently and well, taking care of fault tolerance. The running guideline these days is that a single GPU is going to fail every 1,000 days. And just kind of a standard MTBF for that. And if you're working with 3,000 GPUs concurrently, then on average, you're seeing 3 GPU failures a day. And so, how much runtime you get between failures in the context of a large scale training run that's going to run over a time spanning weeks, then becomes non-trivial in terms of, you start a job, it's a batch processing job that needs to run, and then, oh, by the way, it stopped because of a failure. What do you do? So we've automated recovery for those kinds of things, and we've made it so that that automatic recovery happens so seamlessly that you can actually watch your run logs and not have to do anything about it. So that's a non-trivial thing. And then deploying the jobs in terms of orchestrating this, because we're providing this in a way that's dynamically available from job to job to job. You orchestrating that, you're actually setting this up. It's not a dedicated set of nodes that you're working with in a static sense. This job is running on this set of nodes for now, and then when that job finishes, you want it available for the next set of nodes. And all of that has to be done in a dynamic fashion. So on top of the platform itself, which is the bit that's actually referenced by the performance note at the bottom, we have our software stack that takes care of how you're actually able to get that code to run and be able to do the distributed training that way. And so the software stack on top, streaming data set, Composer, LLM Foundry, these are the pieces that we've provided for everyone to have access. These are open source libraries that are available for people to use to do this same kind of training. So at the scale of doing training from scratch, and given the amount of resources that are involved, it's something where you don't really want to have to lose a lot of time at great expense to figuring out all of the knobs that you need to turn and getting all of the hyperparameters dialed in for what's going to work best in these kind of situations. And so we've put together the code and config in the LLM Foundry to help you be able to leverage Composer and streaming and running evaluations with the evaluation gauntlet automatically and correctly. And then what happens is when you run it in the platform, we're collecting those data in our MLflow deployment. And so then you have MLflow to be able to monitor the metrics, see how things are going in terms of whether you're tracking loss curves or whether you're looking at other evaluation scores to see where things are going with your models as you train them. That stuff's baked in and built into how you run. So we get that configuration and code already set up to help you. The Databricks platform in general has a breadth of things that are just outside of the training itself. So you see that the MLflow and the multi-cloud training are on the right there, the last two, and which basically what we just talked about. In addition to that, we had Lilac, which Databricks recently acquired because we loved working with it so much that we wanted it to be a part of our platform to help people explore the data that they're working with, make sure they're checking what they've got, be able to filter it as needed based on if they want to change the data mix that they're putting into their data set, into the data sets for training. And then, of course, we used Spark and our notebooks for the pipelines to do data preparation and get those things lined up and ready. Again, back to that slide showing Replit, just how much of that work is actually done in data preparation and making sure you have the right data set and that is formatted properly before you use it to train. And then again, Unity Catalog for the governance story. Now, these are all the pieces that go into doing this, and this we did it for building DBRX, and naturally, again, the point is that these are things that are available for everyone to use. So that again is the really big takeaway from what we've seen in the market and what we've been doing and what we get from the learning experience of building and training DBRX ourselves. That our platform really provides all of those pieces. And so one of the things that's nice is that the more of those pieces that are already built for you, the more you can focus on your particular domain, like the specific expertise that you have and what you're bringing to the table. If you have a platform that takes care of many of these infrastructure and management challenges around how your data is and these kind of things, that gives you the space to stay focused on the problem that you're trying to solve for the interesting things that you're working on. If you're working in climate science, you want to be a climate scientist. You don't want to, also develop a deep expertise in systems and infrastructure, if you can. I mean, the idea is that we're more efficient as individually when we're able to collaborate with or have the tools and the leverage of platforms that can help you get things done. So that's one of the big takeaways from us, from our learning experience working with DBRX. And obviously, it's one of the guiding principles. I often like to think about the fact that we think about our research team as being sort of like customer zero for what Databricks can do. Because if our researchers can't train models and can't show how these things works, then the platform needs to be adjusted to be able to meet their needs. All right, so the last big topic is fine-tuning. We just talked about the training from scratch. We're going to dig back into the fine-tuning bits, talk a little bit about continued pre-training, instruction fine-tuning, and then we'll play back a demo that one of our senior software engineers put together for us. All right, so fine-tuning keys here. Back to the second two thing now. Instead of talking about training from scratch, we're going to be focusing on these two. Getting down to the size of a training task that maybe more people are actually taking on as being more tractable. And again, you're optimizing a model for your use case in the specific, given the power and generality that it already has. Continue pre-training. The opportunity with continued pre-training is that the text, you don't have to worry about providing structure. You're just going to be feeding the data in tokens and letting the language itself inform what the model needs to learn. So the key is that you're talking about domain-specific language, but you don't necessarily have to go about giving it exact prompt formats and things like this. So here, again, the example that I mentioned earlier, where an organization takes, so like all of their documentation as the corpus, and then feeds that in to their continued pre-training use case. not question and answer already formatted, just literally all of their documentation. Excuse me one moment. On the other hand, with instruction fine-tuning, you're talking about formatted data that's set up specifically to help guide the model to be able to do the response that you want, given the input that you expect from the user. So here you see that the prompt and response has been formatted with JSON. You got the curly braces, you got the colon notation for the name value pairs. And you can provide, hundreds of examples, typically more like between 3 and 10,000 examples is usually a really good number to get to. And these examples are then going to be ones that are going to help you optimize your model for the specific interaction that you want, while remembering and not having too much impact to sort of the broad knowledge that's available that the model has already had encoded through its pre-training. So you take your data set, whether it's the unstructured one, what you might use for continued pre-training, or whether you've actually structured and created prompt and response pairs to use. You customize the model that you have. One of the open models that's open source that you can get, anything from Hugging Face, anything that we already published in our model registry from our marketplace, and then you can customize that to your needs. When it's done, you own the weights. If you want to download the model and run it on any infrastructure, you can run it locally on your laptop. If you've got something where you can use a quantizing, you quantize it and then be able to run on your laptop, or run on a different infrastructure. Like once you've done it, the model is yours to work with, and you go from there. But of course, we also offer the model serving so that you can actually serve it directly from our infrastructure as well. So specific use case for a chatbot would be one use case. Task specific. The task specific example we're going to be showing a little bit later is as generating SQL queries. So taking, natural language input of like, show me the thing and, find all of the ones of this and what have you, turning it into SQL based on the fields that are in your database and based on its schema. So that's an example of a task specific model. Domain specific, again, like which knowledge base is really specifically the one you want to be working with. And then the generic use cases, the basic idea is that essentially if you're looking at something and you've tried prompt engineering and then you added some retrieval from some documents and you're passing that into your model and your model's responses still aren't quite fitting. They still aren't quite giving you the quality and consistency that you need for your application to work. Then in addition to the prompt engineering, in addition to the RAG, you can fine-tune the model that you're working with and make it domain specific in the ways that will help adjust its behavior to match what your needs are. Some of the things that go into this space actually are criteria that may not necessarily be about accuracy and quality. It may actually be like a speed concern. The larger models, just by dint of the fact that they require so much more computation for every prediction, you may want to actually figure out how to get a smaller model to perform in a manner and a quality that's comparable to a larger model, so that you can get the speed gains and the computational cost gains that come with that. So you can reduce cost and optimize a model for your needs to help with performance things, in addition to talking about whether or not it's about the accuracy. So there are a handful of things that go into that. So our platform, one of the things that's going on with the data intelligence platform at Databricks is that we're baking in the capabilities so that many of these things you, again, don't have to learn everything from scratch to make it work. So we're creating a fine-tuning API that people can use. And this API means that all you have to do is supply your data and put it in the you still have to format the data and have it ready for you to go. But then when you make the API call, then we'll take care of all the things it takes to actually make the training run available and register the model in MLflow registry so that you can then deploy the model for model serving afterward. The creating of the fine-tuning run is a relatively straightforward call to a Python function where you're going to then be able to just pass in the values that you need to pass in, given the where the training data is, where the model registry is that you wanted the model to be registered to, and then and how much training you want done, and then you can monitor that run through that interface. So these are the bits that the SDK takes care of for you, making it very straightforward and easy to do. You evaluate it, deploy it, and there you go. And let's run the demo of that. And I've got a video recording from Nancy Hung, Senior Software Engineering here at Databricks.
Let's take a look at how you would build custom models on Databricks by building a text-to-SQL chatbot.
Is the audio going through okay? Can everybody hear it all right?
Yeah, sounds good.
Fantastic.
Say that I'm a marketing analyst who has a lot of data on Databricks, but I'm not sure how to write SQL. I can use Databricks to fine-tune a language model where I can ask questions to get SQL that I can run in the SQL editor. I have this data set with many examples of my database schemas and questions I would like to ask my model, and valid SQL queries that I want to teach my customized model. By using the Databricks GenAI Python package, I can create a fine-tuning run on a model of my choice. Here, I chose MPT7B as a lightweight model that will be fast to serve, point to my dataset, and configure where to register my model to serve it. I can monitor my fine-tuning run by getting the events for my current run, which has been created. And here's what the run events would look like for a run that has completed. In MLflow, I can monitor my training run and see training metrics for the model learning on my data. And finally, I can deploy and chat with my model in Playground. On the left-hand side, we can see the base MPT7B model that was not fine-tuned. On the middle is the MPT7B instruct model. And on the right is our fine-tuned model, specifically with the SQL data that we had given. We can see that the base model does not really know how to respond to SQL, whereas in the middle, the MPT7B instruct non-fine-tuned model hallucinates a result given the question. And on the right-hand side, the fine-tuned model just gives us a valid SQL statement.
Okay, so that's really the key here, that with some fine tuning, in this case, we used a 7 billion parameter model, so nowhere close size-wise to the largest models that are currently in vogue. We're delivering the exact experience that people want. They want a SQL query to be returned from the prompt and are able to get that customized and dialed in through this fine-tuning interface. So that's the sum and substance of what we wanted to talk about today. Right here, we've got some resources. We'll be sharing the links. We'll be sharing this slide deck after the fact so that you have access to these resources and take a look at what we've got there. There's constantly a stream of new content coming out, so we'll make sure to follow up later on on the various updates through the University Alliance to make sure that you see what's coming out next. And I really appreciate having this time with you. Thank you for letting us present and giving us a chance to chat with you about both the general sense of what it is that's going on with language models, and then also to give you the specifics about how Databricks does it. Thank you very much.
Thanks, Kobe.
Any additional chat questions that would be useful to cover that haven't been discussed yet?
Yeah, so one person asked about links to resources and slides. So I've captured all the links and I'll make sure to send that through on the I'll post them in the University Alliance faculty Slack community, and I'll also post the links in the meetup group as well.
Brilliant. Listen, I want to thank Sam for being on this call and answering your questions in the chat and being responsive. Karen, thank you so much for hosting and getting us going here, making sure that everything flows well. It's always it always takes a village, and it's always such an important thing for like hosting an event or having these kind of conversations to have everybody pulling together. So thank you both very, very much for making this happen.
Thanks, Kobe. You're
That's
too
great.
kind.
Thanks, Kobe.
Yeah, thanks, Sam. Yeah, I appreciate it. And everybody, thanks for joining. We're happy to have you and share this content with you. And open invitation to share your feedback with us as well. So I'm in the different community spaces for the University Alliance group. So if you have any feedback, positive, negative suggestions, please feel free to share. I'm always happy to hear and improve our offerings. I guess there kind of is a question around get the notebook of the demo presented.
I will double check if that notebook is publicly visible. I know we have some example code published elsewhere, so I'm happy to share the resources and make sure that if what we have is available, that you have the link.
Well, it looks like Christopher has a question. Is there a smaller model that you might recommend that students can quickly affordably train to gain hands-on experience that gives a similar example to the text to SQL?
Top of mind, how small is smaller is the question that comes to mind for me. I think that there are a number of examples that are out there that are in the neighborhood of, say, 1.3 billion, 1 billion parameters. And these things are start to get to the place where they will fit on a laptop and without too much struggle. And so I think there are a number of examples. Exactly which one I would recommend right now, but the things move really fast. So what's best today, is going to be different than what's best, next week. But a couple of other interesting things to note is that our observations again about like how performance is something that you can squeeze a lot of juice out of smaller models if you optimize them for exactly what you want them to do. There've been a number of things that have been published where people are saying, look, we can compete with GPT-4. There's been a number of those things that have been published, and I hope that my interface is telling me that my internet connection is unstable, so I hope you haven't lost me from an audio and video standpoint. But just the thing that comes to mind is I think that there are lots and lots of good models out there, and so it's almost like you kind of can't go wrong just trying one of them and taking it where you need to go. But then again, given the size parameters and constraints that you want to have for your students' lab experience or for their own just sort of general exploration, I think that you can get a number of things that would work easily in a local environment and in smaller lab environments.
Cool. Also, Kobe, Sam posted a model from Hugging Face too. So
Brilliant.
yeah, great resource. Great. Yeah, Christopher, let us know how it goes. Great. So I don't see any other questions, so I think we can close it out here. So thanks everyone for joining again, and thanks Kobe and Sam. It was great to have you. And I hope everyone, you have a great rest of your week.
Awesome.
Fantastic.
Thanks so
Thanks,
much.
Karen. Thanks, Kobe. That was great.
Bye.
All right. See you.